got a notification. But lovely, perfect. Thank you so much, everyone, and very good morning, good afternoon, good evening from whatever time zone that you're joining in. And I hope you're enjoying the security summit here. And I've been enjoying the previous sessions. It was really great to know all those zero trust capabilities around Azure and how to implement it. Uh, in this session, basically, there is going to be a bit of double-clicked version, I would say, just a single part of it. I wouldn't say it's going to be a full view of Zero Trust, but we'll see specifically what we can do around Azure Private Endpoints. And you have done a really great job sticking around until almost towards the end, but we have great prizes over here, and that will be towards end of this session and towards end of this overall summit. So, without further ado, first of all, to introduce myself, my name is Tushar Kumar. I am Cloud Security Lead at Codec Ireland. I'm a Microsoft MVP in security. I also do a podcast series called 12 Reasons Why, and you have the link on the screen, which you can use for checking out different podcasts as well. So in today's session, we are going to do a deep dive in more of Azure Private Endpoints. Azure Private Endpoints, and basically the title suggests, right, how you're going to architect it. And basically, nobody cares a lot about, okay, how the traffic is going and what exactly is happening as long as your application is working, right? That's why it's more of a silent security we are talking about. So we will be looking at how the private endpoints is changing the game and basically how you're looking at a more of a precision in implementing security in especially network security within your overall Azure environment. We have been doing great within our bare bones of virtual machines, bare bones of our servers, racks kind of things. But in the cloud world, with the all past services coming in and all, how you're going to do that. So without any further ado, I'll move to the next slide, which is basically so in order to understand what is happening in the market at the moment, and you must have seen different slides throughout the day around there is data breaches, there is compliance issues. So the cloud security landscape basically consists of multiple components that sits under it, and basically each has its own attack vector, I would say, and you have to prevent it from that. And basically that's where you look at possibilities of what you can do, where you can prevent that. uh, Second thing is there is a lot of control that we have lost from our side, and it's a good thing, it's a bad thing on the both sides, right? So when we talk about platform as a service, you always have a fight between agility and the inherent public access that your endpoint gets, right? Because when you deploy an app service, when you deploy a storage account, basically, both if you go back in time, I'll not say much, but it's just a couple of decades, you will see your app service used to be a virtual machine having IIS role on it and running basically IIS and your web services on that. So everything below the IIS is taken out. Even the IIS is taken out. Now you just get a service where you deploy your code, and basically your web page is available after that. Basically, that is really good for us. We are not managing anything from a manageability perspective. It's all good because just because it is hosted somewhere else, just because it is hosted in some shared environment with the assurance from Microsoft, it has all the boundaries and the segregations within that. But still, in order to access those, we have the public endpoints. We have to go through public endpoints there. That was the challenge that we had from past services. Now, we need to make sure that we eliminate the public exposure as much as we can. We mitigate the risk and align more with zero trust that we just discussed in the last session there. And basically, all of that to ensure whatever systems that we are designing, whatever system we are putting in place, it is secure and invincible. Okay, so this is going to be the today's session's objective, right? We will demystify what exactly is private endpoints and private links. We will try to look at how we can do the isolation, how we can prevent from any data exfiltration. We'll try to look for any architectural patterns that, okay, what kind of design that we should be looking at. And also, it won't be a demonstration, but we will be looking at how Private Link will help you in terms of understanding the zero trust alignment. Also, as part of this, I'll do a quick demo on our Azure portal just to show that how easy it is to go through this and basically how easy it is to deploy a private link. Okay, so the first question that a lot of people have asked me earlier on as well during my customer meetings and everything, that we are talking about private link, we are talking about private endpoints. What are these? Like, is there a difference between those, or it is just again one of those Microsoft quirks where they have changed the name to something else and it is quite similar and you're getting confused around this? So the good news is Microsoft has not changed the name. It's basically there are two different, there is a slight difference between those. So private endpoint is basically a network interface for, let's say, a service which goes into any virtual network and it has a private IP around it. The private link is basically the methodology and I would say, the binding power that will basically be connecting the private endpoint and the service together. So in other words, it's basically anything coming in, private link will be the person taking out, private link will be the person taking out the message, and basically private endpoint will be the person receiving the message and then giving it to the whatever tenant that we are talking about. Okay, that's very simple and everything. You'll see my cats coming in the corner, but it's more of an expression there. But what exactly is private endpoint? So private endpoint basically gives you a secure connectivity to your Azure services. So the likes of your app services, so the likes of your, I would say, storage account. Before the private link era, I would say, before the private endpoint era, what we used to do is we used to connect our storage account over xyz dot Microsoft, the sts dot on Microsoft.com, that the link that storage account usually gives, or xyz dot Azure websites dot net, and that usually resolves to a public endpoint, and we used to go directly to that. We had options earlier on to restrict it with firewalls, making sure you have, like, let's say, allowed IP addresses, you have VNet integration kind of things, but it was never possible to do a proper way of connectivity from A to B going totally private. So that's the problem that private endpoint is solving. As part of this as well, you get a private IP. That's I would say that's obvious, because you are creating a you're creating another instance in your virtual network, so you will get a private IP out of it. You will be able to basically, although the service, as I mentioned, it is sitting somewhere in the shared service model with proper boundaries and everything, but still the service will appear to be in your private space, which is your virtual network. You can basically disconnect, you can basically block all the public access and just use things privately as well. And the traffic flows, basically, it's not like it is totally getting disconnected, and basically we are totally removing all the dependencies on public. But if you know, and if you have heard on Microsoft side, there is a thing called Azure Backbone Network, which is a Microsoft owned network that they follow for the services to communicate to each other. The private link basically integrates with that, and that basically gives you an ability to connect to your past services, likes of your storage account, your web apps, your search service, and so on. We'll see that in the coming slides as well, that what all is possible by bypassing the public internet and going through the Azure Backbone Network. So the way this overall thing works is you go with you are the service consumer. Microsoft has the PaaS service. First thing is it comes down to, okay, what service supports. So basically, what service supports your private link? We will see that in coming slides. So the moment you know, okay, this is my service, this is my SQL database. Let's take an example that supports private link. We go with that. We create a private endpoint there. We send a request where we want to connect to that. Basically, that's sent, and that's basically the decision is made around you have an option to approve or reject that. Once that is done, basically you have an approved private endpoint there, and based on that, you can do your DNS configuration. So basically, there is a part of DNS configuration that we will see in the future slides as well, but you will tell your DNS, okay, now this is how you are going to go to this instead of going to the public endpoint. Okay, so within private link and private endpoint, what exactly is there and what exactly it provides you? It basically helps you with private connectivity, as the name suggests. It helps you secure your PaaS services specifically, which is anything related to Azure SQL, Azure storage, search service, like you name any PaaS service. I believe most of it has support for private links now. The dual nature of it is two things. One is you can see it on the left hand side here. So that is more of a connectivity of to your PaaS services as a consumer, but you can also use this as a provider. So when I say consumer and provider, it's more like, okay, let's say I have a service that I want someone else to connect to from their Azure environment over private connectivity, right? So basically, the way it works is you have to put a standard load balancer in front of it. You will have your private link service deployed there. You will get a string that you need to put in the private endpoint of the other side, where what we are calling here as a consumer network. So I'll just zoom in on this. So what we're calling it a consumer network, and with this, you will be able to set up this commit connectivity straight away to the services that we are looking at there. There is a bit of different things that you need to do, and we will see that in the demo. I have this as a demo for you guys, specifically understanding what exactly it looks like in practical scenarios. So overall thing is what is the intent from Microsoft side is to provide all the cloud interaction, making it more private, just so we are reducing the attack vectors. We are making sure there is no open ends or very less open ends in terms of getting it. So how this all comes together. So we are talking about again the private link scenario, as we mentioned, about provider and consumer. So what happens is provider configures services behind the standard load balancer. Then we are looking at private link, which gets created on this. You create the front-end IP configuration, you create the NAT rule within that, which is basically going to be used. On the consumer side, you will be deploying a private endpoint, and you will define while you're creating that private endpoint, right? You will be basically mentioning the private link service ID, and that can be in a different tenant as well, a proper, fully qualified string of that service ID. Once that is created, basically you have three settings on your private link. You can make it basically whoever has access, they can do it. There is another one, and you can do another one that is allowed for everyone. So anyone can access, anyone can try to connect to your service. The moment you put in your private link service ID on the consumer side, you will get a approve or reject request on your private link here. You need to basically do your decision around, okay, let's say I did an approve. The moment I did an approve, basically the connection gets approved. If you do a reject, that will be a reject. And let's say if you don't want them to connect to the resources there. So this is basically a proper flow of setting it up. What exactly the security benefits it is bringing to table? It's basically the direct benefit that you're getting is your past services are not going to public internet. That's the direct benefit. Everything is going through your Microsoft backbone, so your sensitive data is not leaving the Azure network boundary. Okay, that is reducing your attack surface significantly. Your services are being protected, all the services are being protected. And the last one is more around, so the last one is more around the advisory. So even though if you put private endpoint, that doesn't mean it will stop it immediately. So you must explicitly configure your firewalls, your services to basically stop allowing anything that is not coming from private link. Okay. Now, in order to architect this and in order to make sure this is being all aligned with zero trust, it's basically what we are looking at how private link helps us, right? So the zero trust core is when we try to understand zero trust, we saw in the last one is you never trust, you always verify, and you assume breach. Private endpoints basically eliminates the trust of based network location. So if you think of Azure SQL database firewalls, right? So in that case, you have to put in specific client IP addresses who is going to access that. Same for your basically your storage accounts. You have to provide a specific IP addresses. In that case, you are trusting that IP address range that basically breaks the first principle that we have there and within zero trust, right? So many of the past solutions, they contain their own ingress or egress control functionalities, but and you can use these controls to secure your network access, but what happens is it basically not, I would say, sufficient in order to go for more of a zero trust approach. And basically, it creates a bit of a diffusion of access control and logging in terms of making sure you get enough visibility. So anything and everything that is going in and out, you are basically, if you're using private endpoints to make sure everything is coming in through a private network, you have everything connected there, and you're making sure you're reducing your attack surface there. That is basically aligned with your two of the zero trust pillars. One is using the least privileges, where in your services are communicating to each other, and it is not relying on a high level ACLs there, and also assume breach. Anything that is coming in, it has to come through a private network, not from anywhere outside. Okay, so you are basically reducing your attack surface quite. I would say you're making it invincible a little bit. What's the strategic move behind it is not just from the technical config perspective, but you are making a good bit of move towards zero trust architecture when you are getting into private endpoint. And zero trust is a beast of its own, so you won't, I would say, achieve this with just one private endpoint, I would say, but it's a good starting step. Let's talk about private DNS. And private DNS, someone will ask the question why, and the answer to that is you need to tell someone if you have changed your name, right? That what's your new name? Because you had a resource, and that resource was listening on, let's say, a public IP address 108.65.77.36, something like that. Okay. Now what you have done is you have stopped listening from that. You have changed it. You have made sure now I'll only listen to 10.0.0.4. In that case, you will have to tell someone, you have to make sure the DNS is aware of what exactly is happening and how exactly is happening. In that, then only you will be able to see, okay, this is what we are going to do. So the first one that comes into picture is our DNS, which is set with private DNS zone, and you are only accessing it from Azure. So in that case, what happens is you get in, you have a client VM in here, you have a private link or private endpoint here, which is 10505, and basically this client VM tries to access this. So the moment you type in AZSQL1 database windows.net, ideally the way it should be going is it should be giving us the public IP of, sorry, uh, yeah. So this guy should be giving us the public IP of Azure SQL database, and it will give you the public IP address of the Azure SQL database when you try to resolve it outside somewhere from your network, but that will not be allowed because we have that setting in here. So how the DNS resolution will happen? So the first one is it will go to the Azure provided DNS. Azure provided DNS will give it a response that, oh, you're asking for something. We have a private DNS zone created for that. Okay, that private DNS zone in will basically have a DNS entry, and that is basically a CNAME entry that will say anything that says AZSQL1 database.windows.net, that will be considered as AZSQL1 private link.database.windows.net. Perfect. Now we have converted that. It is now the private link. Now, in that case, now what we are seeing is what is the IP address for that? Then another DNS query will happen that will basically say, okay, tell me what is the IP address for this one. So in that case, the response will be 10505, which you will be setting in here. So anything that relates to Azure SQL 1, that will go to 10505 instead of going to the public IP address of that. And that way you will be able to make the private connection in here. So as part of the private link configuration, whenever you are doing it, whenever you are deploying it, you will get a DNS tab there to deploy. You can pick that you want to put it in an existing DNS. You can pick that you don't want to put it in a DNS, and you will configure it later, something like that. But whenever you do, and whatever DNS solution that you use, you have to use these two entries, which is basically one is going to be the private link dot your service, whatever URL that your service use. In databases sense, it uses database.windows.net. In storage, it uses storage.blob.microsoft.com. So you need to see that, you need to get that from the service, and then you need to put that in here specifically for making sure your service is able to reach that. So this is more of a single DNS solution, but again, you need to tell in a hub spoke scenario how you're going to reach to that thing. Okay, so in this case, if I just zoom in a little bit here, yeah. So this is a hub spoke scenario that we are looking at, and we have two here. So one is this our hub, one is our spoke, which is sitting in here, and another one is sitting in here. Okay, we have a client machine, and both are going to use the same thing. And there is a private link over here. The moment you are going to try it again, you need to have a DNS zone that basically points to both of the virtual networks. So the moment your this virtual network link is going to make sure the moment you are going to ask for, okay, tell me who is that private link.database.net, it will just pop up exactly, okay, this is the IP address and this is where you go to do that. Okay, the next scenario basically is our DNS forwarder. Okay, so and whoever does a complex DNS solutions, right? They know about the pain of using DNS forwarder and basically using creating your DNS forwarder rules in your internal DNS and then making sure everything goes up there. So in this scenario, basically what we are looking at is uh, we have a hybrid scenario. We have an on-premises machines, which is your client VM, your internal DNS, and that basically is trying to access this. Let me go back a step here. Yeah, that machine is trying to access the AZSQL database.windows.net. In order to access that, it shouldn't be going through the public internet. It should be going through the private link there, because when you go through public internet, although there will be a possibility that you can resolve this, but on the database here, it says no public access allowed. Should any request shouldn't be coming in from a public IP. That will be coming in from the private endpoint only. So in your internal DNS, what you will be doing is you'll be creating a conditional forwarder, which is basically going to be for database.windows.net. That conditional forwarder will point into your DNS forwarder server here, which is going to have its IP. And that server is going to point to the Azure provided DNS here. So which is basically the same IP address 168.129.16. You will have a private DNS zone, same as the previous scenarios, which will be doing the same thing. You will have two entries, that is, one is the CNAME and one is the A record, which is basically going to talk about, okay, that name corresponds to the private link name, and the private link name corresponds to private IP like this. And the response will be here is your 10505, and you will your server, your client machine will reach to 10505 just because you have express route here. So you will be able to, if you have a VPN express route, your server machine will reach here, and then you will be able to go into your SQL database. Most efficient one, and that's the one I recommend in terms of when we are looking at overall private endpoint solution. You have like multiple stuff going on around private endpoints, and you have multiple deployments in there. You should be looking at private DNS resolver. So private DNS resolver is again a platform service given by Microsoft, wherein you can, which is basically works as a DNS resolver, as the name suggests. So in this scenario as well, the same. If we take the example, so you have a client machine and that is trying to access the SQL server. It will try to access this. The moment it tries to access database.windows.net, the internal DNS will take over. It will ask the conditional forwarder here. It will say, oh, database.windows.net should be going to 10.101.254, which is the private DNS resolver. Now it will go in and ask private DNS resolver, do you know that this name? What's the IP of that? Then private DNS resolver will go back to the Azure recursive resolver that will give us, okay, there is a database zone for that. There is a DNS zone for that. That DNS zone will again be called, and then that DNS zone, the first thing that it will give is the CNAME of that. That, okay, this corresponds to private link.database.windows.net, and then it goes to, okay, that's the IP of that private link.database.windows.net. Okay, so that's how the DNS resolution will happen, and that's how you will be setting it up in terms of making that accessible. Because the biggest pitfall I have seen people getting into when they are doing private link deployments and private endpoint deployments, basically at any point they don't uh, do their DNS neatly. They just start picking whatever they get in the Microsoft next buttons, and then they will end up having 5 different DNS zones in 5 different regions, or 5 different uh, subscriptions. And what will happen is you will end up having multiple records sitting there, and you will not be able to manage it perfectly. So this is the way you should be doing it, and you should be trying to minimize as much as you can the private DNS zones to make sure that you have a single place to go to in terms of any in order to resolve any issues there. So yeah, we talked about the services, that there are services that supports private link. I'm not sure how many of you have seen Azure Graph earlier, sorry, Azure Charts earlier. So Azure Charts is created by one of community members, and it's a really good resource to go to. We'll try to open it here. So I have it. I have the filter on here. So if you go in, you do maybe just go in and start, and you just select, okay, I want the services, and the services that supports private link. So you will be able to see that what all services that
We had
support.
time.
Sorry,
तो time है दिन है.
sorry, is someone speaking there?
Hmm.
I,
I think
I,
it's all good. Tushar,
Sal.
please go ahead. Yeah, we
Okay,
just have 10 minutes.
okay, yeah, that's perfect. That's not a problem. Yeah. Okay, so we have the services looking at, that we are looking at here. These all services basically supports Azure Private Link, and basically you can go through the list. If you are deploying something, you can take a look at that, and basically you can make a decision around that, that if you want to deploy that service or not. Okay, private endpoint in action, you will see a very simple example first, which is just a virtual machine trying to access a web app. So the web app, if you try to deploy this from, if you try to access this web app from internet here, you'll get a 403 that says access denied there. But if you try to access it locally, it will go through the private endpoint and basically sorry, I'll just mute one of the participants there. Yeah, so if you try to go through, yeah, through your private endpoint, basically you will be able to access that. That's a very simple example of private endpoints and why you should where it goes. This is one of AI Foundry examples, I would say, which is very much I would say, this is a hot topic at the moment. So anything and everything in here sitting in this environment, right, is going through the private endpoints. And that's how you should be designing your infrastructure. Because if you leave the AI search open and you just have some, let's say, specific IPs allowed, you're still leaving a possibility of someone abusing that by just mimicking the IP address or just trying to spoof the IP and use this service, right? In terms of it, in order to reduce your attack surface, you need to make sure you're using private endpoints for all. Okay, so the last one, and I wanted to show this as a demo, which is basically example of private link. How so? Somehow the screenshot is not that much clear, but what we have here is we have a, I would say, a service machine. So let's say this is company B on the right hand side. Uh, this is company B, and this is company A. So company A has a client who wants to access company B's this virtual machine. Basically, company A can have, let's say, a HR management system that has some component or some APIs sitting in here that we want to access, but we don't want to go through a private go through a specific connectivity. We can go through. We don't want to connect those two networks with the VPN or anything. We want to go through a private link here, and we want to use Microsoft Backbone to use this. So this is a simple deployment, and I will just quickly flip back to the Azure. Okay, so this ISSC demo RG, and I'll show you the resources. So we have a couple of resources deployed in here. Come on, go back here. So first one is you have just leave the disks for that's for the virtual machines. We have a standard load balancer, as I mentioned earlier. We have a couple of network interfaces, which is basically talking to each other, which is basically being used for different services. We have one private endpoint. We have one private link service. The public IP address is just for me to access that virtual machine to show you that demo. So this is the consumer machine. This machine is going to access this particular machine. So if I take a look at the machines and their virtual networks, right? So first one, the consumer machine is sitting in my PE virtual network, and the service provider machine is basically sitting in my virtual network. Okay, so they both are in a separate virtual networks. If I show you here, there is no virtual network peering done. So there is no virtual network peering, so there cannot be a connectivity between both of the machines. And the machine IP address is 10.10.0.24, what we are looking at. And if we look at the load balancer IP address, it's basically front-end IP address is 10.0.1.4. Okay. Now what we have done here is we have deployed a private link service, which the private link service, it comes with its own network interface, which is basically being used for the connectivity to the virtual network. If you look at the private endpoint connection, there is a my private endpoint connected, which is sitting on the other side. You do a NAT configuration here, which basically is pointing to our load balancer, that 10.0.1.5 we saw a couple of minutes back. Okay. The access security that I was talking about is more of role-based access control, restricted by subscription, and anyone with the alias. So if you do anyone with alias, it's basically gives you a URL. Basically, it's kind of a URL that you can put on the other side when you're creating this connection. And then you have to choose between if you want to approve or not. You can also set it up for auto approval. So if there is any request that comes in from a subscription that you want to allow, it will automatically approve as well. So now that we have that, if and my this machine is basically running IIS on this. So at this point, if I try to ta-da, if I try to go back here, and if I do MSTSC, and I think this is my consumer machine. So if I try, and that's the reason I had just a public IP address, it is only associated with the consumer machine. So if I go in the consumer machine and if I try that IP here, great. So I had that page open already, but if you see what we are going is 10.0.0.5, which is on the other side. So if I just Teams Windows. So yeah, so if you look at this VNet range, address space, and if you see the connected devices here, that's the PEVNet, and it is going to 10.0.0.5, which is basically your private link connection to the other side. So basically it is going to your consumer, because from consumer VM to your service provider VM for the service, as we have defined it for port 80 there. Okay, yeah, that was it from my side. I believe if you have any questions around that, if not, thank you so much for joining, and thank you so much for the organizers for organizing this great event. And you can connect with me on all the social platform. I am available with Follow Tushar, and you can basically send your queries to me there as well.
Thanks a lot, Tushar, for this wonderful session. And thank you, everyone. Feel free to ask any questions you have to Tushar. Otherwise, you can always reach out to him at a later point in time. So with that said, I think, again, I'd like to really thank you